So let us start our lecture today and tonight. Today is February 4th, 2021. So as usual, so let us see our schedule today. So I think our lecture tonight will be shorter. Okay. So actually we covered almost all of the principles of object-oriented programming. We have a few things maybe to just to review or recap: polymorphism and typecasting. Okay. So let us see our resource base. Okay, so your test will be test one will be to when February, for my section, February 23rd. Okay, and the test will be online. You can take from home or any quiet place. You have to have a working webcam and a good internet connection. So your test will start before 30 minutes before your lecture time. That means 6 p.m. and it will end after 30 minutes that we end our lecture. That 7:45, right? So that means still you can start it before 8:15. So but I like you to start as soon as possible. Okay, so I will be on Teams. So if you have any question during the test, you can, I think, oh, you are not allowed to use any device, anything. But if it is really urgent, then you can send me a text message on Team. Otherwise, you are not allowed. I think you will not have an issue. Okay, so in our previous lecture, we discussed abstract class and interface. Okay, and then today we will discuss polymorphism. Actually, polymorphism we already discussed, and then module 3, part 5, pulling it all together. That means typecasting. Okay, so polymorphism is one of the properties, principles of object-oriented programming. Poly means many, morphism means form. So an object can have multiple forms in multiple situations. Okay, so that is what we will discuss in this lecture. So we need to learn how does polymorphism actually work. In order to understand that, actually there are two kinds of polymorphism. One is compile time polymorphism, another is called runtime polymorphism. So in order to understand those, we need to understand inheritance clearly. Okay, without understanding inheritance, so we cannot understand. Okay, so now for instance, we discussed that in our previous lecture. So mammal class is a parent class, right? And you see the dog class and cow class, these are two subclasses of mammal class. So you see the arrow sign from bottom to up. So this is the inheritance sign. It goes from bottom to up. Okay, inheritance sign goes bottom to up. Okay, so for instance, in the you have a two, this is plus sign, that means a public method in mammal class, it method you have, and it has its own toString method, mammal class has, and dog class inherits the it method, and it has its own toString method, and cow class it inherits the it method, and it has its own toString method as well as. Okay, so one thing that in order to understand this, we can do a quick like, what can you can say? Okay, so we think you can see all dogs are mammal, right? If say arrow, this arrow inheritance, this arrow means that all dogs are mammal. all cows are mammal, right? But no dog is cow, no cow is dog. Okay, but in on the other way, so then are all mammals dog or are all mammals cow? No, right? So there are some mammals that are dog, but there are many mammals that are not dog. Similarly, there are some mammals that are cow. There are many mammals that are not cow. Okay, so the opposite direction is not true, right? So now what will happen, the rule of thumb is that when you call the eat method, okay, so for instance, mammal, we have a mammal, let us think that this is not an abstract class, okay, this is regular concrete class. So then we have an object m of mammal class is regular object, and if we say again, if we say m equal to new dog, okay, so then reassigning, so initially we assign m as a mammal, and then again we are assigning m equal to new dog, reassigning m to be a dog here, okay, and then if we say m dot eat, so then what will happen, the eat method, which eat method will be executing, is this coming from mammal or is this coming from dog? Okay, I think that a dog has its own eat method. Okay, so that means dog is inheriting here this method, and but dog has its own implementation and cow has its own implementation of eat method. So here question is that m is a dog and it likes a dog, right? So here, so then here m, this m will call the eat of dog. Similarly, when if we reassign m equal to new cat, okay, so m dot cat, it will call the cat's eat method. Okay. So here what is called m is a mammal. M is a mammal, so you see that ML type is mammal, right? ML is a mammal, but it refers to a dog instant here, and here is a cat instant. Two things. Is a mammal, that means we can say that we said a few minutes ago that there are some mammals that are dog, right? There are some mammals that are cow. So that means is said that this is we are assigning all mammals. Here or M is type of all mammals. But here whenever we say M is a dog, but since there are some mammals that are dog, we are concising those dot object to this M. So here this M changes during the runtime, okay, and it's behave directly. So here at this point it will call the dogs method and it will call cat eat method. We can see through a live program that what we get output. But has anyone any questions so far? Okay. There are two kinds of polymorphism that I didn't mention. There are two kinds of polymorphism. One is compile time polymorphism, okay, and another is called runtime polymorphism. Actually, by polymorphism, we say runtime polymorphism. That is called, so in there are other names. Compile time polymorphism is sometimes it is called early binding, okay, or static binding, and then runtime polymorphism is called late binding or uh, hmm, are called dynamic binding. So this is a good interview questions. Okay, so if you are doing good in an interview, so that you can at the middle of the interview, you may expect that you will be asking a question from about polymorphism. Okay, so polymorphism here, what is happening over here, it is happening dynamic binding, late binding. Okay, so then there is another example of compile time polymorphism. Actually, compile time polymorphism, that means compiler compiles it or detects any error or issue of this polymorphism during compile time. Okay, so we already discussed compile time polymorphism a number of times. You may remember that or do not remember, or may not remember, but not, don't worry, I will uh, help you to recall. But can you please tell us what is we call compile time polymorphism? We already discussed that. Anyone remember what is called compile time polymorphism? Do you remember that we discussed method overloading? Okay. So method overloading is a compile time polymorphism. Okay, is an example of compile time polymorphism. But in generally, that is called static binding, that is called early binding. Okay. So actually, polymorphism is related to in inheritance. Okay, so although the compile time method overloading happens within a class, but method overriding happens within parent class and base class. So this is a good another interview questions. What is method overloading and what is method overriding, and what is the difference between method overloading and method overriding? Okay, so this concept you will need when you develop, if you are going to develop game. Okay, so if you develop, whenever you develop a video game, for instance, if there are multiple players, okay, so then in that case, you will need like uh, uh, dynamic binding. For instance, this is player one, this is player two, and this is your main game. Okay, is player will have its own according to the subscription. Player will have his own level of accessibility. Okay, so for instance, it's same thing is actually this is the base class, and these are the child class. Child class. Okay. So we have two more slides. Let us see the slide. What does this slide say? Okay, so it is a so like any regular variable, we can create a class, an object, on sorry, an array of object. Yeah, that was similar type. Okay, so here this is for in loop I equal to 0 to enemies dot size, whatever size you are here 3. So it will, so enemies 0, first one 0 dot update ei, that will call these enemies, the enemies zeros, update ei method. Okay, and then so that kind of sign like changing screen once, whenever we moving one player to another player, it will be changing their UI. Okay, so that's all for about polymorphism. So, but I think this concept is sometimes tricky. I think so. It is good that if we go with some live program. But before that, has anyone any question? Okay, I will go through some live program, but before that, let us see that we have one more slide. This one, putting all together, actually typecasting. So like regular variable casting of regular data type, we can also cast object type. Okay, so okay, this is a good new slide. Actually, I think this semester we got it new. So it says putting all together. So whatever the object oriented programming principles so far we discussed, we have all here together. So mainly we discuss inheritance, right? Overriding a method, like overriding the toString method or a method in the base class, in the child class. We discuss abstract classes, we discuss interface, we discuss polymorphism, and previously we discussed array list, right? So, and whenever we combine together, one more thing that we need to we should discuss typecasting. Okay. Okay, so this is a UML diagram. You see that. So this one is what is that called? Interface. So this is the symbol of interface. It says, and whenever you see, okay, so actually you see that I think I would take here to better understanding. Okay, so one thing that I want to tell you that inheritance sign, it goes from down to up, bottom to up. Inheritance symbol goes bottom to up. Okay, bottom to up. Okay, so this dotted line, it means interface, and the solid line, it means like class. This is the like class. It can be an abstract. If it's an abstract class, then there will be a symbol over here like this, abstract class here at the top. So here we discussed that if an interface contains a method, then every class, every subclass that inherits the interface must override, must rewrite this talk class, right? So the talk method must be overridden in the doc class, right? And then doc class, it has its own stuffs, own method. And this class, this cat class, it does not inherit the interface, but it inherits the memo class. So the breathe method will be here, and then if we override the breathe method, then we will get it here. This is the override symbol. So okay, so I think this is another program that we discussed maybe in our last lecture, but good thing, I think if it is a good program, then I can copy it and then I can discuss this, okay, in a live program. Okay, a few more slides, but one thing, only one program if you understand this. So in order to do this, so let us mammal, right? Mammal. mammal class inheritance. Okay, I have in Java, I have in C#. Okay. But that is a different program, so let me make it another one. Java, so mammal class inheritance example 2, I can say. Okay, let us get the copy from here. Let me get the copy. Okay, so we have abstract class mammal class, and it has this breathe method, but it is not abstract method, so it has its own implementation. Okay, and we have interface is called talkable interface. Okay, and it has a talk method. So this method is by default abstract. Okay, so you cannot have any implementation on body. And then dog method, dog class, it inherits. Why it is getting here? I think I'll copy and paste. So so I copy and paste. So miss some error. Okay. So this dog class, it extends mammal class and it implements the talkable interface. That means actually it inherits both mammal class and talkable interface. So interface inheritance, when we inherit an interface, we use implements keyword, and when we inherit a class, we use extends keyword. So then talk methods must be overridden. Otherwise, if we do not do this, then this program will get an error. Okay. So here we have our main method, for instance, here. So until now, main method will give you just a hello world. It is not using okay. Okay, the program is running so far. Now let us understand how we can explain. Okay. How we can explain this? Okay, something you see that somewhere. So if you want to run this program, it will not run, it will give us an error. Okay, so there are 6 errors. You see that there are 6 errors. So let us understand that why the error are coming. Okay, first of all, okay, this program is better to explain with Eclipse or NetBeans or IntelliJ. So okay, so let us say that whether, okay, so we don't need this one. So let us say that whether each of these statement is valid or invalid. Okay, so you will get some test questions. Please be careful about this, okay, and give attention so that everybody understand this. Okay, so C1, is this statement is a true or is a valid or invalid? Okay, so then in order to understand whether this statement is correct or incorrect, that means valid or invalid, okay, that means do not see the right side. Understand the formula or logic. How do you check yourself? Ask a question. Are all cat cat? Are all cat cat? Are all cats cat, right? Yes. Okay, from that is true. And one thing is that, so here we have interface talkable, right? Talkable is interface and mammal is an abstract class. So these cannot be instantiated. So we cannot have the left side, we cannot have mammal, we cannot have okay, so on the right side, I'm sorry, on the right side we cannot instantiate an abstract class or an interface, right? So on the right side we cannot have either mammal or either interface. So this statement is false. Okay, at a glance I can see this is false because on the right side mammal is an abstract class, so I cannot have this, so this is false. Similarly this one, a mammal class is an abstract class in this perspective, so I cannot have these ones, so I cannot say these two statements. Will you understand this? Okay.
Yes.
Okay, because mammal is an abstract class, so I cannot instantiate an abstract class. On the right side, you cannot have abstract class, or you cannot have interface on the right side. So any statement that has on the right side either an interface name or an abstract class name, you can say that those are invalid. Okay, those two are gone. Okay, now so let ask, go one by one. Ask questions. Are all cat cat? If the question is true, then this statement is true. Yes, we know all cats are cats, right? So there is cat class already. Class need to be defined. Okay, so all cats are cats, so this is allowed. All dogs are dog. Yes, right? Are all dogs dog? Yes, so this statement is correct. So now ask a question. Are all cat dog? No, right? Actually, no cat is dog, but we can ask a question even if we get one no answer. We are asking question, are all dogs dog? Are all cats cat? We are getting yes answer, but here can we ask, are all cats dog? Maybe there are some cats that they look like a dog, but there are many cats they do not look like a dog. So this statement is no, right? So then this is false. Similarly, this one, are all dog cat? No. Okay, so then that is false. Okay, now let us see this one. So we see, are all dog talkable? So then is, you see that the dog, whether dog is implementing talkable? Yes, right? So that the statement is true. But here, so is the cat, are all cat talkable? No, cat does not implement trackable interface. So this one is false. You understand this one? Why this is false? Because it does not cat does not have talkable properties. Okay. Now this question, ask this question. Are all dog mammal? So yes, all dogs are mammal, right? And are all cat mammal? Yes, all cats are mammals. So these two are allowed. Mhm. Okay. Now let us see all by all of this what it will do. So it's a m2 dot breathe. So m2 is a dog. Okay, so m2 is a dog. So what the breathe function, what the breathe method is mammal, right? So it inherits, dog inherits the breathe method, so it will print this one, generic breathing. Okay, and cat inherits the mammal. Okay, and mammal has the breathing method, so breathe method, so it will call, okay, m3 print I have a, so this breed, one thing that you need to be careful over here. So this breathe method is overridden over here. Okay, so cat will call its own method, but dog, since dog does not override the breathe method, then it does not have its own breathe method. So what breathe method it will get? It will get from parent breathe method. Okay, but cat has its own breathe method, so it will give its own breathe method, whatever I have here in this. So the rule of thumb is that if we inherit property from your parent, as long as you have your own property, own money, you have to use that. And once your own money has shortage, if there is a shortage in your own money, then you can use your inherited money. Okay, so you have to use your own money first. Okay. Okay. So this is a tricky question, like this one, the like line number 36 is a tricky. Okay, because breathe method is overwritten over here, although it is supposed to have an override annotation. If do not have override annotation, then still it works in Java and same programming languages. Now last see this one. So m2 dot talk. Okay, so what is m2? M2 is a dog instant, right? Does it have a talk method? Yes. Okay, so but okay, talk method, true, it should give us an error. This is the tricky shot. It should give us an error. Let me double check. Okay, I got it. So m2, although m2 has the talk method, you see that, but m2 is a kind of mammal. It is not a dog. So this is why it will give an error. Now, if I have d1, right? d1 dot talk. If I have d1 dot talk, then this d1 dot talk, these will be fine. Is that this d1, I have d1, right? d1 is a dog, but this d1 dot talk, it will work. Okay, but this m2, okay, M2 actually this statement is like this, here, and M2 equal to new dog, and here, and M3 equal to dog. Okay. So here, you know that in a slide, I can go back to slide. We discussed that this is M2 is initially declared as a mammal, but it is assigning to a dog instance. Okay. But here D1 is declared as complete dog, and then later I said D1 equal to new dog. So then this D1 will be able to get this dog all properties, a dog. Okay, so this is yes. Okay, so actually here we can say that dynamic binding is happened here. So here dynamic binding. Yeah. Okay, has anyone any question?
What were the different types of binding again?
One is called early binding or static binding or compile time polymorphism. Another is called dynamic binding or late binding. So let us go
Okay,
to the
so they're
slide.
just other names for each other.
In some slides we will have this, we discussed previously. Okay, so late binding is called dynamic binding. Okay, actually actual polymorphism is called late binding, and in order to understand polymorphism, if you understand this question, then it's fine. Okay, now YAML class. So I'm gonna give you for polymorphism. I can give an example polymorphism. I can say polymorphism. I can convert this program in C# quickly. So I can give you okay. Let us convert this code quickly using from C# to from Java to C#. Okay. You see that there will be no change here in this code. The main method, all of these code are fine in Java and C#. So I can write down quickly these codes. Okay, the change will be here, right? Let us make the changes. We need to have this console.write line. Okay, so what will be changes? Can you please tell me? Can someone please guide me? What changes we will need? I'm converting. I copied program from Java and I'm converting to C#.
You need to change out the implements and the inheritance of the extents.
Yes. So first of all, I did quickly and the print method. Okay. So you understand this. And then here, we need to change here, right? So what changes I need to do here? Can anyone please tell me? This is in Java.
It
So
changes to a colon.
Okay. Yeah. Tell me, please. I don't know. I don't know anything. Whatever you will tell, I will write it down. I will type in.
So I guess instead you would use class dog.
Class dog.
And then colon.
Then colon.
Mammal, comma, talkable.
Mammal, comma. Talkable. Okay.
And then that first bracket.
Okay, thank you. So first bracket. Okay. Okay, that's it. And anything in line number 18?
A class cat, colon, mammal.
Like this. You said like this.
Yeah.
Actually, I don't know, it may work, but I know for sure C++ it will not work. You need a space. In C++ you need a space, but let me see if it works. Okay, so this is why I intentionally did not give space. Whatever you told me that I just typed in. Okay, so then here, is there any change here? I'm sorry. I'm sorry. Is there any change here?
Yeah, delete out override.
Okay, delete it.
And then add override into the method name.
Where?
After void.
Are you sure?
No, I'm not actually. Go ahead and put
before
it
void, not after.
Yeah, before void.
Yeah. And that was the thing I was. Okay. Then what do you think? I think it is. Let us try. So it is good that, right? For instance, error in line number is marked as an override, but is not suitable. Okay, so line number 25. 25. Oh, 21. Public set. Show this. No. Override must proceed before. Okay, type. Okay, that's good. Override, which says that compiler says this. Okay, override must proceed before. But I believe. So the error, it does not say actual error. I believe the error is coming from without space. Let me keep the space and see. No, there is another space needed here. No, breathe. Okay, cat.breathe is marked as a override, but no suitable method found to override. Okay, breathe. Oh, cat.
Is it because the original method needs to be virtual?
Okay. What is there? What do you think? Breathe is breathe. Then number 20. Cat.breathe is marked as an override, but no suitable method found to override. Sure.
Don't we need to make the breathe method virtual?
Abstract? That is I'm thinking in C#. No. Oh, I see. It needs to be public. It should be public. Java works with the default. Java has a default access modifier. Okay, so if you do not give anything access modifier here, Java consider as default, and that works within the same program or within same package. Here we need public. That is the thing. Okay, and same thing we need public over here. So let us go this and fix this one first. Okay, so public void breathe.
Yeah, it's got to be virtual. Otherwise, it's not going to let you override it.
Which one? Which
The
one?
public virtual. Void.
Okay, I got it. Virtual is only C++ and C#. I forgot it. Okay. Okay. Yeah. Thank you so much for recalling. So we need to make it virtual. Otherwise, it cannot be overridden over here. Okay. So then now let me get rid of the public. Then what it says. What I was thinking. Okay. And also it needs to be public, because Java does not have, C# does not have. So here it says virtual or abstract method cannot be private. Okay, so virtual or abstract method cannot be private or default, so it must need to be public. Okay, it's a good thing for me also. Okay, so now I'm giving you this code also to practice. Okay, now let us give typecasting, right? One thing is the typecasting. I should have some example of typecasting. Typecasting. Maybe that one. Okay. So in order to understand typecasting, so here let us review the typecasting that we know from general perspective, or general programming perspective, with general variable, not with object-oriented perspective. So here I have variable y double, right? So double, as long as it's double, if one of these, either numerator or denominator, is double, by default double, decimal with decimal value, then the result will be in decimal place. Okay, but here this is called typecasting. So changing one type into another type variable. So this typecasting is temporary. So then here this y will be, so here this one y will be, printed as 5.9. over here it will be printed as 5.9, but here it will be printed as 5. only 5. And but again here it will be printed 5.9 because this typecasting is a temporary statement and it does not change permanently. So here let us understand these three, first three. So you understand this one. So y is 5.9 here, right? But here this one y, so if we this one into y typecasting is, that means it's enforcing y value to make it integer. So it will just get rid of the part with decimal and afterwards. So then int y equal to 5, but again if you print y, then y value will be still the previous value. So everybody understand these three statements? Okay, this another quick quiz question. Okay, so what will be the value of g equal to, if you say 20 modulus 20 divided by 2? Okay, and then if we have modulus 4. Okay, so then which one will be executed first, this part or this part? Okay, so the arithmetic operators have a higher precedence than this modulo operator. So this part will be executed first. So we got 20 divided by 2 equal to 10, and 10 modulus 4 equal to 2. So then output will be g will be 2. Okay, and then if you make it float, then it will be 2.0. If you make it double, then it will be 2.0, same thing. Okay, so I think everybody understand this, right? Has anyone any question about this? Is everybody good? Okay, now if you are good, if you understand this, then let us come to typecasting in the perspective of object and classes. So here number is a class, right? Is a wrapper class, is a built-in class. This number n1 and n2 are numbers, not an integer. I is an integer type. It is a integer also a class. So this I here is an object. This n1 and n2 are object. This is not primitive data type. Okay, this is not a primitive data type. Int is a primitive data type, but this is not a primitive data type. This is a class, a wrapper class is called, and D is also an object. Okay, so there are two type of casting. One is called upcasting and another is called downcasting. Okay, upcasting, that means putting double an integer to number. Okay, upcasting is automatic. So in order to explain this, so if I have a class number, okay, and I have a subclass integer, and I have another subclass called double, right? So in number system, everyone understand this, right? So all integers are numbers, all doubles are numbers, but not all numbers are integer, not all numbers are double, right? There are some numbers that are integer. Okay, so everybody understand this, right? This concept. So since we can say all integer are numbers, all double are numbers. So the arrow goes from bottom to up, right? So we can remember that this is called upcasting. So this up arrow is up. Okay, so you can remember that. If you remember that for inheritance symbol, it never comes downward, this arrow. If you draw an inheritance symbol and give the arrow downward, that means you did not understand inheritance. Sorry. So now, so since this is true for inheritance, all integers are numbers, all doubles are numbers. So that means you can say in typecasting, that means upcasting is automatic. Okay. So you can remember that upcasting is automatic and there is no issue. That means here you have an integer number, right? So if you want to convert the integer number to n is a number, so then it is okay. It is upcasting. So integer converting, but putting a value of integer value to a number, it is automatic, right? It's automatic. It's called upcasting. Okay, it's fine. It's okay, and it is also putting a double number into an integer number. It is also upcasting, and it is also fine. Okay, so now if I print at this point, if I print here n equal to n and I equal to I. Okay, and here if I print n1 equal to n1 and d equal to d, then it is fine. Okay, so then let us see that output will come correctly. There is no issue here. Okay, n1 equal to 5 and I equal to 5 here, n1 equal to 2.5 and d equal to 2.5. Okay, then there is fine. So that means upcasting over here, no problem. Now the problem is without casting. So that here over here we got I equal to 5, n equal to 5, d equal to whatever 2.5, n1 equal to 2.5, right? So but now can we say I equal to n or d equal to n1? Just reverse order. Can we say this? So in reverse order, that is downcasting. That is downcasting. Downcasting. Okay, it is not okay because all numbers are not integer. Okay, all numbers are not double. Okay, sorry. Initially, okay, since all numbers are not integers, so some numbers there might be double numbers that cannot be fit in an integer type value, in integer type memory space. Okay, but so in order to resolve this issue, so you see that this statement, this if we run this program will give an error in line number 30 and 31. Okay, So it is giving an error in line number 30 and line number 31. Okay. So downcasting is not automatic. Then how to resolve this? How to solve this? Okay. In order to solve this, we need to do explicit downcasting. So explicit downcasting is here like this. We need to cast. So that means converting integer n over here to, okay, to with integer, this one with integer, because there are numbers, all numbers that you put in a filter. So we are coming there, we are telling that there are some numbers that are integer, but there are some numbers that are not integer, right? So if you put a filter over here, and if you do filtering, that whatever numbers are coming, if it is integer, then it is going to I, because I is an integer location, space object. Okay, that is kind of filtering. Okay, that is kind of filtering. Okay, that is called, these are called downcasting. Downcasting means when you come through downward, from up to down. Okay, downcasting is not downcasting. To use in computer. Okay, downcasting is not automatic, but so in order to resolve this issue, what do we need to do? So these two statements will not work. Okay, but if we do this, the same thing, just do downcasting, then it will work. So now, do you understand casting concept from here? If you understand type from first part that we have discussed, typecasting for regular variable type, and the second part here we have discussed typecasting for object, class and object, okay, class type. So if you understand this, we can use this knowledge in our previous program. So for instance, a number can be a mammal class, an integer, it can be a dog, it can be a cat, this can be dog, and this can be a cat, and this can be a mammal. So same thing, you applied that, it can for this is called explicit, this is called explicit typecasting. So downcasting, or also this is called explicit, it is downcasting. This downcasting is not automatic. Is not automatic. Okay. Downcasting is not automatic, but upcasting is automatic. Okay, so this program in Java, you can do same thing in C#, I believe. Okay, so I'm forwarding this message to you. You can practice this. Okay, so typecasting example with I'm sorry. Okay, so I can convert quickly this to this, 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 this. Does C# have this wrapper class same name? I'm not sure. Identifier expected out 99. Oh. Oh, so then it has maybe different name for for C#. I will check it and I need to change it. Okay, so if we have this knowledge, then I can put what is that called? Our previous program. So here we can do downcasting over here. So here, so what is not allowed? So M2. Okay, so M2. So here M2 dog is it here or this line? What is that for? Not allowed. Line number 43. 43. Okay. So here or here. No, it is not working here. So not here. So somewhere I can use to M2 no like this. Okay, got it. You see that this is, so this is not allowed, this is not allowed, this is not allowed. Okay, but this is allowed. This is allowed. You understand? This is allowed. So that means because downcasting here. So whatever my mammals object where I am enforcing over here using a filter to make it a dog. So now this is what, but without this is called typecasting over here. and without this casting it will not work. So this is a good example of typecasting. So oh, it should not allowed, right? I know that it's not allowed. Okay, it will not allowed, but this will allowed. And same thing, it should be applicable in C#. So what we can do a typecasting. We can do an explicit typecasting, or it is called downcasting. So everybody understand this typecasting now? Has anyone any question? Okay, how many are there? Okay, till 24 people. Okay, has anybody any question? So now this complete our study of object-oriented programming principles. Okay, so now we have completed 1/3. We can say 40% of this course. Okay, so we have completed up to module. So within first 5 weeks, we have complete object-oriented programming principles, and these you will need practice. Okay, so please keep practicing. Then you will see that you will, whenever you do some practice, then you will understand. Especially there are some difference between C# and Java. For instance, Java does not require the virtual keyword. C# and C++ need it. Okay. Okay, if you don't have any question, then we can wrap it up tonight. Okay.